completely or wasn't done very well. So I am going to show you pictures and we're going to talk about pieces of this chart, but I'm not going to fill it out and have you copy it down because I don't think that is going to help you very much. Okay, so you should have this chart in front of you. You might want to also have a separate sheet of paper to kind of sketch these graphs that I'm going to give you. Okay. Nope. All right, here we go. This is what kind of a graph right here? Is it a quadratic, cubic, quadric? What is this? Quadratic. Okay, so I've got a quadratic right here. And we can see, how many roots do we have? 2. Okay, do they have to always look like this, where they go through the x-axis, or what kind of roots could you have if it doesn't actually cross x-axis? Imaginary. So you can have, if you don't count multiplicity, look at your chart, I'm kind of answering this for you. Don't count multiplicity, you can have 0 to 2, so you can have 0, 1, or 2 roots. Imaginary, if you count imaginary, count multiplicity, you will always have 2 roots. So I need you to change your chart from what I wrote on Friday that you copied down from the board, that if you ignore multiplicity, you could have 0 to 2 roots. Okay? Let's talk about this. We've got 2 shapes. This one is a positive A, right? So this one would have to be a. See how it has no real roots here, but it will have 2 imaginary? Good. Okay. How many points do you need in order to tell what kind of equation it is? 3. I need to know, if I just had 2, well, I'd think it's a straight line. If I had 3, I know it goes here, down, and comes back up. Okay. How many max or mins does it have? How many global max or mins does it have? And remember, global or absolute means the biggest or the tallest. It still just has 1. Okay, last thing, and then I'm going to move on to cubic. What is the end behaviors? Where, as x approaches negative infinity, y approaches? Infinity. As x approaches positive infinity, y approaches? Infinity. Okay, what if it's negative? If the graph is negative. They both approach negative infinity, right? So they both either approach positive or they both either approach negative. Okay, let's look at cubic. Here's a nice cubic graph for you. So, first of all, how many points do we need in order to prove that it's cubic? 4. I would think 4. Because you need to have 1, 2, and 3, we would just say that it is a quadratic, right? With a cubic, I need to know at least that it's coming back up. At least 4. Okay, I would say 4. You don't need 5, but 5, of course. More would help, obviously, but minimum, you need 4. Yes?
How do you do that graph? Because like, when you do it on the calculator, that's not what happens.
So this is not x to the 3rd. This is x to the 3rd plus 2 times 2, okay? Because I wanted you guys to better see the roots, okay? So how many max and mins do I have? Okay, and I'm always going to have 1 absolute. One of them is going to be taller than the other, or they're going to be exactly even, so that would be the absolute. How many roots do I have? So if I'm looking at not with multiplicity, I have 0, because I could have this go up here. It could go like this, up here, right? It could have, well, the problem is it's going to have at least 1. So I would say 1 to 3. And it's going to have at 3 if you include multiplicity. So it'll have at least 3 if you include imaginary. Okay. What about end behavior? As x is approaching negative infinity, y is approaching? Let's look at it again. As x is approaching negative infinity, y is approaching? Negative infinity. As x is approaching positive infinity, y is approaching. So it's either, they're going opposite ways, right? Okay. So, and it's the opposite if it's negative. Any other questions on your chart that you want answered about cubic? All right, I'm going to move to quatric, or x to the fourth. Okay, what do these look like? W's or M's. Yep. The top one is positive A, the bottom one is a negative A. Okay, this is tricky because I did not draw this to show it. How many roots does it have? It shows 2 on this graph, but how many roots is it going to have? 4. Okay, if we look behind Allison, there's another one where I dropped it so my mins are below the x-axis. Okay, it has, it'll have 0 to 4 real roots, but it will always have 4 if you include imaginary. How many maxes does it have? How many mins does it have? Okay, so it'll have 1 max and 2 mins always. And it'll have 1 global max and 1 global min. Okay, they might be the same, or absolute. All right, do we see that it changes directions at its roots? Okay, and at its max or min. End behavior. If they're both approaching, or they're both approaching, do you start to see a pattern? Wait till we get to 5, and then we'll talk about that even more. Any other questions from your chart that you want answered about quatrics or to the 4th power? Okay, the 5th power. All right, I want you to notice what's happening here. It skids along. It looks a lot like what picture? Does it look like to the 2nd, to the 3rd, or to the 4th? Which one? It looks a lot like to the 3rd, except you see how it stays on the x-axis for a longer period of time? Okay. So I like to think of it like a penguin. Here's the penguin. It's down here under the water, comes up to under the water, lands and skids across the ice and launches itself into the air. Okay. Now a penguin would fall back down, but that would ruin my whole thing. Okay. So let's pretend it flies. What swims in the water and flies? So maybe like a puffin. So a puffin's underneath the water. Puffin, it's a type of bird. It's under the water. It skids along the ice and then flies up into the air. Stays there forever. Not in reality, just in this graph. Okay. So what do we need to talk about for here, guys? How many roots do you think this has? If we're looking at a pattern from quadratic to whatever you call a 5th power, how many roots do you think it has? Look at your roots on your paper. We have quadratic, cubic, quatric. 5th one would have how many roots? So we went, what did we do? We went from roots, we had a quadratic had 2, a cubic had 3, a quatric had 4, right? So a 5 roots. Okay. So it can have up to 1 to 5 roots for the 5th power. Okay, if you don't include multiplicity, but it will have 5 if you include imaginary. What else do we need to know about this? Yes? All right, this one doesn't have anything that adds or subtracts to it. Let's see if I can pull up another one. If my internet works, I can show you a different kind. Sometimes it does, sometimes it doesn't. Let's see. This is great if you don't have a graphing calculator at home but do have a computer. This site, www.demos.com/calculator. Not found. It's not letting me work. It's a must be a closed site on my. Let me try one more thing. If I hit Google, will it bring it up? Graphing calculator. Nope, not affing calculator. Graphing calculator. There we go. Maybe it'll bring it up this time. Let's see. There we go. Okay, let's adjust this a little bit. It might take me a minute because I know I don't want y x to the 5th because it looks like my graph, right? And it's not great. So instead, let's move this around a little bit. So I'm going to put parentheses, and I'm taking it to the 2nd. But then I'm going to times it to the okay, so it kind of is showing me 3 roots here, but I don't like that. I want more. I want to show you that it has the whole 5. So let's change this. Yeah, that's good. There we go. 1, 2, 3. That shows me 4. So there must be an imaginary one in there. But see how we're starting to get the little bumps there? Let's see if I do this. Let's do one more. No. But literally, this is how I got our graphs that we worked with. Okay, I'm having trouble not getting an imaginary root here. But do you guys see how moving this around gets different adjustments for it? Okay. All right. So we could go, if we've got 5 roots, here we've got 3. So if we added a 4th and a 5th one, we could have how many? 1, 2, 3. We could have 3 max or mins, right? But we're always going to have one that's the greatest. I'm going to go back to this. What about our end behavior, guys? One side goes to. So, do you guys notice a pattern? If it's to an even number, the infinities both, the end behaviors both go to the same infinity. But if they're an odd, they go to the opposite. Okay, let's look at 6 and we'll be done, guys. So here's a picture of 6. And this is moved above the x-axis, so it looks like we only have 3 roots. But we could have moved this below and we would have had 1, 2, 3, 4, 5, 6 roots. It's to the 6th power, so I could have 6 roots. Right? It's going to have 2 maxes and 3 mins, or the opposite, depending on if it's positive or negative. It's going to have, like 1 global or absolute. The end behaviors are both either go to positive infinity or both go to negative infinity. Any other questions about this? Do you feel better about your chart? Okay. Should have it nicely filled out now. If you want, again, I recorded this so you can listen to this again if I went too fast or if you lost something from it. Okay. And now you should be able to do your homework. You have the roots. You can figure out the roots by setting it equal to 0, each part equal to 0, and finding it. And then you should be able to tell, using this chart, where it's going to change directions. So you have the rest of the hour to finish up this chart or work on your